Okay, so as in the last video, we have derived the formula for calculating the energy of the orbit, and that energy was kinetic energy, right? Today we're going to derive the formula for calculating the potential energy of the orbit, right? So we know that if here we have an electron, right? So there would be a potential energy between the two charges, right? This is one charge I have, which is a positive charge, nucleus, and nucleus has positive charge, right? Positive charge, and this is the other charge I have. So basically this is I have q1 and this is I have q2, right? And there is a radius as well. This is the radius, right? This is the radius r, which is radius between these two charges. But here if we're going to take these two charges, we have to take their signs as well. For example, if I'm taking the charge of electron, I need to put the sign as well, and that would be negative, right? And if I'm going to take the this charge, right, q1, so there would be positive e, positive ze, right? So let me write here. Here we will have potential energy, or you can say electropotential energy. Potential energy, or you can say electropotential energy, right? Let me highlight this first. Okay, so let me write here electropotential energy. Potential energy is equal to K, where it has a value of 1 upon 4 pi epsilon naught into E, that is first charge, right? Because we know that we have formula q1 q2 over r square. So instead of that, let me write first q1 q2 so that I can make you guys understand very easily, right? q1 q2 over r, right? This is for the potential energy. So let me highlight this first. This is for potential energy. Now I'm going to write PE. PE is equal to 1 by 4 pi epsilon naught into Q1. Q1 is E, right? E, and that is negative E, right? And Q2 is the ZE, and that is positive, because we know that in the neutron we have positive charge, and those charges basically is equal to the atomic number of that particular atom, and it is a charge of positive E upon R, right? Upon R. Now if I'm going to solve this, potential energy will gonna be equal to you know what, minus ZE square by 4 pi epsilon naught R, right? 4 pi epsilon naught R. Now let's substitute the value of R instead of R, as you can see in the denominator, right? I have guys written the value of R, or the derived formula of R, on the right hand side. As you can see, n square h square epsilon naught upon pi m z square. So let's put that value in this formula, right? Putting the value of R, the value of R in potential energy formula, right? Potential energy formula. Let's put that. Wait, before putting that, let me highlight this, right? So that it can look good. Okay, I'm using this color now. Just gonna highlight this line. Okay, now let's put the value of it. P E is equal to minus Z square by 4 pi epsilon naught. Instead of r, let's put its value, right? And that is n square h square epsilon naught upon pi mz square, right? So n square h square epsilon naught into pi m z square. We know that that is in the denominator. When it will going to go up, it will be multiplied, right? So I have written like that. Let's multiply this, or wait. Yes, let's multiply this now. Potential energy is equal to, let's see if something would gonna be cut, right? Okay. Now see, this pi will be cut with this pi, right? So what's remaining up now? Let's write that. Wait. Okay, now what's remaining up is minus z square, both z, right? Z square e 2 plus 2 is 4 m over 4. Now see, n square h square epsilon naught 2 times means epsilon naught square, right? So minus z e square e power 4 m in upon 4 n square h square epsilon naught. Now see, this relates to this, right? Instead of just ignore this minus sign, and in the denominator ignore 4 right now. Everything matches, right? Now we need to make this 4 as 8, as you can see, so that we can have same constant. So making this 4 as 8, we need to multiply and divide 2, multiplying and dividing 2, right? Wait, let me write this with another color, or I'll highlight. Multiplying and dividing 2, right? Multiplying and dividing 2. When we have multiplied, what we got here will be, wait, what we get here will be potential energy is equal to, let's shift this minus sign to this 2, right? So minus 2 into, wait, let me separate this a bit, into minus 2 into z square e power 4 m upon, now see, 2 into 4 is 8, right? 8 epsilon naught square h square n square. Now let's you know what, separate the constants, right? P E is equal to, minus 2 is constant, right? Minus 2 is constant, into e power 4 is constant, m is constant, upon z square is not a constant because atomic number of every atom would be changed, right? 8 is constant, epsilon naught is constant, Planck's constant is constant, but shell number is not constant. So z square by n square are not constant, however this is constant. Now as you can see up, this whole value is equal to what? This whole value is equal to 13.6, right? So I can make this whole value equal to 13.6, right? This whole value equals to 13.6. So now I can write potential energy is equal to minus 2 same, right? Minus 2 same into E4 m upon 8 epsilon naught square h square is the constant, and its value is equal to 13.6 into z square, which will gonna be changed, and upon n square, which will gonna be changed as well, electron volt, right? So this, we have derived the formula for finding the potential energy of an orbit as well. Potential energy of an orbit. Now let me highlight this. so I can look good. Today we have derived the formula for calculating the potential energy of an orbit as well. Here we got, right? Okay, so in the next video we're gonna calculate the total energy of an orbit.